Welcome back, everybody. Today we're going to do definite integrals. So again, I should preface this in front of every single one of my videos. You should be looking at the theory in the textbook. You should be looking at the theory on Khan Academy. You should look at what the definite integral means. What is the fundamental theorem of calculus? Because really, I'm just going to jump in, hoping you've got that background. And my job is just, I got the easy job. Do some examples, make it look fun, and have fun. So when I see an example like this, how do I deal with it? Well, first of all, it's a definite integral because there are bounds. What do those bounds mean? You can see future videos in my application section on what I do with the bounds. But right now, I just want to integrate this, a definite integral because it has definite bounds. How am I going to integrate this? No problem. Forget about the 1 and 4. It has nothing to do with what I want to do right now. The fundamental theorem of calculus says if you can integrate, you should integrate this first. If you can't integrate it, move on to a different topic. We'll get there. So how do you integrate this? Well, my friends, we would rewrite this, forget the 1 and 4 for now. Rewrite this as a power. I mean, we said this in previous videos. Fractions are not my friends when it comes to integration. I like to rewrite it as a power. And to bring an x up, you negate it. And like, boom, boom, wow, red flag, right? Red flag moment, -1 exponent. Come on now, we've been down this road. Look at my previous videos. -1 represents a log, right? When you integrate a -1, you get a log. So this integral turns into 10 natural log absolute value of x plus c. That is the integral of 10x to the -1. First of all, the 10 comes down because that's a constant. Constants can kick out in front by constant rules of integration and stays there. If you look up the integral for x to the -1, it is the natural log of x. It's a formula. Now, wait a minute. Whoa, that's great, Dr. McCullum, if there wasn't a 1 and 4 there. You're right. I just integrated right now. That's the fundamental theorem of calculus for you. Just good old integrate. Booyah. Now, I like to put this here. It's called my reminder. It's like, hey, whoa, we forgot about the 1 and 4. How do you deal with the 1 and 4? Well, again, I keep saying these 4 words, right? Fundamental theorem of calculus, the FTOC, baby. What does that mean? Well, by the fundamental theorem of calculus, you can plug the top number in, get an answer. What do you mean by plug it in? Well, that's why you need to know your variable of integration, x. You're going to plug it in for x. You can't do this until after you've integrated. Integrate, boom. Now, plug in the top number. Plug in the bottom number. Take your calculator out and get me an answer. That's what you do. Plug in the top number, plug in the bottom number, subtract it out. It's top plugged in, evaluated, minus the bottom, plugged in by the fundamental theorem of calculus. Again, I need you to have gone through the fundamental theorem of calculus through our videos. So you plug in the 4, get a number. Plug in the 1, get a number. Now you might be saying, whoa, you got a plus c. That's a pain in the butt. How are you going to do this without a plus c? Well, look at this. What do you see in here? I see a C and a C. The C's cancel. I really don't need to know that constant because they're canceled out of that expression. And other thing, notice, wait. Why is that a 4, not an absolute value of 4? Good catch, by the way, if you caught that. First of all, let's think about this. What is the absolute value of 4? It's 4. Ha. What's the absolute value of 1? It's 1. So yes, I did intentionally change the absolute value to parentheses because I know what positive numbers look like. And so really, my final answer is 10. Natural log of 4 is actually my final answer. Plus c's cancel because plus c minus c. So I really don't need to know c in this one. That's awesome. Whoa. What about this piece? Come on now. Natural log of 1. Boop. Take your calculator out if you need. This is the number you should know. Natural log of 1 is 0. 0 times 10 is 0. So this whole expression is 0. So really, that is your answer. And there it is. There is your answer to this definite integral. If somebody said, find the answer to my definite integral, there it is. How would I do it? It's called the fundamental theorem of calculus. I integrate. So really, take a look at the previous videos. I think we're on 5 or 6 of them now. Previous videos, go learn how to integrate. If you can integrate, the fundamental theorem of calculus says, I got your back. If you can integrate, all I got to do is plug the top number in, plug the bottom number in, and evaluate. Thank you, fundamental theorem of calculus, because I know how to integrate or anti-differentiate. I didn't know what the heck the bounds did. Now, let me take it a step further in case it's always good to go, why are we doing the bounds? Please see my application parts to see why we put the bounds on. But for now, it's always good to have a running example. The way I look at it is area. I always look at definite integrals as areas. Now, areas there are a lot of reasons we care about areas. To me, I'm just going to do geometry today. What I'm looking at is if I graph this thing from 1 to 4, the bounds, 1 to 4, the bounds. If I graph this thing, you keep saying this thing, Dr. McCullum, 10 over x. If I take my TI calculator out and graph this thing, well, first of all, 10 over x looks like this. That's what 10 over x looks like. This is the graph of 10 over x. So what the integral does, the definite integral does, it does a really cool area game. What it says is these are the bounds of the expression, 1 to 4. Boom. Those are your vertical bounds in your region. We're drawing a region here. 1 to 4 are the vertical bounds on your region. Notice that. 1 to 4, boom, boom, vertical bounds. 10 over x, that's the curve that's bounding it. Could be on the bottom bound or the top bound. It all depends on where this curve is. 10 over x is completely positive, so it's the area. Got to be careful because if this expression dipped negative, you're not talking about area, you're talking about net area. Look at future videos for that. Right now, I'm picking functions that are completely positive, making sure that then the area bounded between 10 over x and the axis, the area bounded by 10 over x and the axis is this number. And that's some cool stuff right there. You're trying to tell me I can find the area of these very fluid, weird geometric shapes. Oh, yeah. One of the cool things about calculus. What is the area of that? I got your back. 10 times the natural log of 4. That's the area of that. That is awesome. A definite integral has one cool thing, area. Now, this area represents so many things and so many applications, okay? Go look at applications to see when the definite integral is very valuable. I'll be putting up videos about that soon. But what we have here is, first, integrate. Boom. Notice I didn't care about the bounds. I just integrated. Then I plugged in the two numbers. Boom. What did it mean? It's always good to have an idea of why would I do this? What is the purpose of this? The purpose to me is this curve, first of all, I got lucky. I made it up. 1 to 4, 1 to 4, 10 over x is completely positive over the interval for 1 to 4. If it's not completely positive, if it dips below, you got to be careful. That's called a net area or a net change integral. You got to be careful of that because sometimes integrals could turn out to be negative. They could turn out to be positive. These integrals, by the fundamental theorem, they could be 0, they could be positive, they could be negative. This happens to be a positive number. Honestly, any number can come out of the integral. I want to keep that in mind. But I get positive here because 10 over x is truly above, okay? 10 over x is truly above the x-axis. And I always keep in my head, the area is a great example for the definite integral. I should put up here net area. Because if this curve was allowed to go below the axis, I'm not looking at area, I'm looking at more of a net bounded area. And that's where you get the 0. If a 0 comes out, that means the area above and the area below the axis cancel each other out. That's really what it means. So what we have here is, one more time, how would I do this integral? Integrate it. What would I do now? Fundamental theorem of calc. Plug the top number in, plug the bottom number in, and subtract. That's it. That's all you need to do. How do you integrate? Look at my previous videos. You want to use sub? You want to E? You want to log? You tell me. What trick do you want up your sleeve? We got plenty of them now. So we integrate and get this number. What does it mean? Future videos will show you that. But for us, a cool little thing is geometry, area. This is the curve you plot. Let's start there. This is the curve you plot. 10 over x. Take your TI out. This is the bounds on the vertical, 1 to 4. What you do now is, this is our lower bound. Typically, that's your lower bound, is the 0 curve, the 0 axis as it's called. If I want a different lower bound, I'd minus something out. I'd go -3 or +4. I can change the lower bound. Heck, I can make it minus another curve. Woo, right? Curve minus curve. And those two could be the bounds of the picture. Good stuff. But what we have here is a very simple bound. And that area is 10 times the log of 4. Excellent. I won't go into much of a digression into area now. Really, today is about, can I use the definite integral? You know, can I find the definite integral? The answer is you should be. No matter which expression you were given, you should be able to find the definite integral. So, for example, we put some bounds on. And the bounds can be any numbers. They really can. They just got to mean something to you in the business world or the physics world or the math world. You pick bounds that make sense to you, all right? If you're looking for income from 2 to 8 p.m., that's why you're picking from 2 to 8, all right? It's all about why is the 2 and 8 relevant to you? For me, I'm just picking two numbers. And now I'm going to pick an integral for us to work on. For example, let's say we have 4t e to the 7t squared dt. So let's say I have this integral I got to do. Again, that says, handwriting's a little sloppy there. It says 4t e to the 7t squared dt. I would love it right now if you paused me and you try to do this without me. I would love that. Try to do it without me. You know I'm going to write all the answers down soon. So why don't you try it? If you look at my previous videos and understand that 2 and 8 really don't matter to the end by the fundamental theorem, really, I just need you to integrate that right now. Forget about the 2 and 8. Just integrate that for me. You should have something that is coming quickly to you, and that is a u sub. When I see an exponential, I typically, not always, typically use the exponent of the exponential as my u. How do I know it works? If it doesn't work, I try something else. So please look back on my u sub video. It's always good to have all techniques ready right now. So derivative on this side is du dt. Dt comes over to multiply. Derivative of 7t squared is 14t. Sweet. I can solve for dt by moving over the 14t. And there we go. Why am I doing this? Well, if you see my previous videos, I write down my substitution, e to the u, and that's du over 14t. My substitutions should always match. This is kind of leftover for me. This is my substitution, and because I made the substitution, this is my dt. Boom. Now, how do I know my u sub worked as previous videos? If all the original letters, variables of integration disappear. If you notice, the t's disappeared. The t will disappear because t divided by t. The t's are gone. I'm left with this expression with just u's. That's awesome. So then there's a constant. I pull it out. 4 over 14. Integral e to the u du. But wait a minute. That is just one of those formulas we got to know. And that is 2/7 because, right, reduce the fraction. 4/14 is 2/7. The integral of eu, you got to know. It's eu plus c. E to the u plus c. But as part of u sub, we then plug back in what u was, right? It originally had t's in it. I mean, my answer has a u in it. Don't like that. So I resub back in at this moment, e to the 7t squared plus c. And now I always put a pause moment. That's what the bar is, more for me for pause. I completely forgot about the 8 and 2. Notice that. I completely forgot about the 8 and 2. And that's my job. When I do a definite integral, I forget about the 2 and 8 and just integrate. This is an indefinite integral because there's no bounds. So I integrate, and that's all I did, a u sub. How do I know it was a u sub? Go look at my previous videos, and my keyword is practice. That's how I know it was u sub. So we have this. Now, click, we're back into definite integrals. I have bounds. What the heck am I doing with the bounds? Thankfully, fundamental theorem of calculus states you can plug the 8 in, you can plug the 2 in, and subtract them, and you'll get your answer. And so I'm not going to be able to do that because these are going to be pretty, really large numbers, but just plug the 8 in, right? So that's 7 times 64, whatever that might be, because 8 squared 64, minus, I know the plus c's disappear because there's a plus c in both of them. Plug the 2 in. So 2/7 e to the, plug in the 2, 2 times 2 squared is 4. 4 times 7 is 28. And so there's my answer. Me and my calculator, well, I think the calculator would give up actually. E to that number is probably woo big. So what do I know? Well, when I take the difference here, this once again would be the area under this curve. This curve, not sure what it looks like, but this curve is sitting from 2 to 8 above my region. So the idea, all right, the idea is once again in my region, in my sweet little region, I thought I could draw a box, but limited board space. What I have is I have my 2 and 8, all right? I have my 2 and 8. I have the axis, and I have this curve sitting up here. What I've just found is the area here, all right? The area there is this number, all right? That's very important. The area here is that number. So this area is this number. What is this curve right here? This funky picture I just drew without a calculator? This funky picture is the graph of this. If I graph 4t e to the 7t squared, so now that I got everything ready, if I graph 4t e to the 7t squared, if I graph that, I don't know what it looks like, just drew a wavy line. If I graph this, first of all, it's going to be completely positive from 2 to 8. I know that. It's going to be completely above the axis. Why do I know that? I graph it. That's why. I just know also 2 to 8 are positive t values. So this thing's completely positive from 2 to 8. So I know that. If it dips negative, again, it's not area. It would be a net area, and you need to look into that. So 2 to 8. This area here of this curve and the axis, this curve and the axis, that's really what I always keep in mind. This curve and the axis, that area bounded from 2 to 8 is right there. A massive amount of area. A massive amount of area is bounded there. How can I find it? You see how I found it. You get rid of the bounds, and you do a good old U sub. And then you put back in the bounds by the fundamental theorem of calculus. All right, guys. Thank you for watching this video. Stay tuned for others.